has pieces of another world in his lab. They are rocks that have traveled from Mars to Earth. And he thinks microscopic Martians may have hitched a ride on some of them.
About a ton of Martian rocks lands on Earth every year, and over the history of the solar system, billions of tons of materials have been transferred. So it's possible that we, in fact, are Martians.
4 billion years ago, when Earth was being pounded by meteorites and comets, so was Mars. Shrapnel from those impacts was flying all over the early solar system. Scientists have found one Martian rock that dates back to those days of interplanetary violence. It's called ALH 84001.
ALH 84001 is a Martian meteorite that formed on the surface of Mars and then was knocked off the planet. It wandered around in space and then landed on the Earth about 11,000 years ago and was found in Antarctica by some US scientists in 1984. This rock is very special.
In the 1990s, the discovery of tiny worm-like structures in the rock turned ALH 84001 into an international celebrity. The claims that these were fossilized remains of Martian microbes have since been discredited. But Ben's investigation of this meteorite might still offer proof of life on Mars, because the rock is magnetized.
You see all these little dots and little features. That's magnetization that originated on Mars. In fact, it's 4 billion-year-old magnetization. So that must mean that there was a magnetic field, a global magnetic field on Mars 4 billion years ago or earlier.
A global magnetic field acts like a protective cocoon. It has kept Earth's atmosphere safe since day one. Without a magnetic field, the planet has no protection from the solar wind, an intense stream of particles from the sun. Over hundreds of millions of years, it can blow a planet's atmosphere clean away. Mars has no magnetic field now, and almost no atmosphere. The magnetization embedded in ALH 84001 proves that 4 billion years ago, Mars had both.
ALH 84001 contains some trapped, we think, atmospheric gases from early Mars. The composition of these gases do not resemble the composition of the Martian atmosphere today, but they do resemble what you might think early Mars had in its atmosphere. Even though today it's cold and dry and not very hospitable for life on the surface, we think in its early days that it had climate which was much more like the Earth's today. Yeah, it was presumably significantly warmer and wetter. There might even have been standing bodies of liquid water on its surface. Its atmosphere was thicker, and it might have been a better place for life to originate.
Since Mars is only half the size of Earth, it would have cooled from a molten ball of lava much quicker than Earth. In other words, Mars could have harbored life sooner than Earth. And Ben's most recent study is closing the link between the biology of two planets. He's discovering that microscopic Martians could indeed have survived the hot and bumpy ride on a space rock from Mars to Earth.
So what you see here is a slice of the meteorite. In fact, on the very outside of it over here on the left, there's a little melted zone, and that's the zone that got heated to high temperatures when it passed through Earth's atmosphere. But most of the meteorite was barely heated at all by passage through the atmosphere.
As Mars was slowly cooling and losing the ability to support life, the last Martians may have jumped ship to our warmer, wetter planet.
Organisms could have hitched a ride on this material that was being exchanged between Mars and the Earth that even potentially seeded the planet on which they landed on. And there's every reason to think that, if there was an origin of life on Mars billions of years ago, that it probably made it to the Earth multiple times.
If Ben is right, the best place to look for clues to the origin of life might be on the surface of a planet that's now dead. Fossils of primitive life on Mars dating back billions of years could still be there. Perhaps the next space probe we send to Mars will stumble across them, and we'll be able to study our long-lost ancestors. But it's also possible the first living things on Earth are still here, lurking in the shadow biosphere. You and I are the latest chapter of a story that's been unfolding for billions of years. How that story begins is still unknown. Did comets seed the Earth with the raw ingredients of life? Was Mars our original birthplace before we jumped to a new planet? Or are we the Earth's second or third incarnation of life? Aliens might be living among us. We might all be Martians. In the end, the stuff of science fiction might lead us to a cosmic truth and answer that eternal question. How did we get here?